a full room. So my name is Pierre. I'm from Marigo, small company in Canada. We make mobile application. This talk is actually sponsored by Relic. So I've got my friend Nate here who's going to be talking more about what they do and how it relates to mobile application performance as well. So that's kind of weird. Let me get the clicker. So just a quick introduction of who I am and why am I here to talk about mobile application performance. So like I said, I work at Marigo. We do mobile application. We mainly do native mobile application, both on iOS, Android, Windows Phone, and BlackBerry. You know, where I'm Canadian, so I got to do BlackBerry phones. So word cloud of, if you look at my LinkedIn profile, that's pretty much what comes up. I did a lot of software development I've been doing this for 15 years now. And Marigo has been working with major brands, mostly in Canada. Some of them you'll know, Aldo, Pfizer. And we built, like I said, mainly native applications for them. Throughout that experience, what we've noticed is when you're making a mobile application, the first thing is the user experience. That's really important. An average session on a mobile phone is between 1 and 4 minutes. And it really depends. If you're looking at tablets, you usually get a longer session time, 2.5, 3 minutes. On a phone, 1 minute, 2 minutes is pretty much what you'll be looking at. So you got to do the most of what you can in that time. And performance is a big thing. Now, if you look at an application, most of them, what they tend to do is present you a shell and give you the information they're getting back from server. And looking at the data that Relic collected in some of our application, the average time it's going to take from my phone to the server and getting the response back is 1.24 seconds, so a bit above a second. If you think about that, so if I say I've got an average session of 2.5 minutes, I've got 1.24 seconds to do all my calls. That means I can do about 120 API calls before my session ends. So the amount of information I can give to the user at that point is limited. And if you start thinking about it, when you're making your application, if you start thinking about it in that sense, how can I get the most information to that user so the application has the most value to them? I can improve their user experience and improve the chances that they're going to keep my application running and keep it on their phone. So I did a few tests at home. These are by no means formal numbers or actual real benchmark, but I tried it out. And so for just checking my balance, starting the application, checking my balance on my bank account, it took me about 70 seconds, and it's 43 API calls. A check-in on Foursquare, starting the application, just doing a check-in, again, 46, reading a message on Basecamp from opening 24. So what we can see is even doing a simple action, people will tend to think of it as just that one API call that's checking the message, but there's a lot of stuff going around it. Downloading the images that goes with that message, downloading the profile information for the user who wrote that message. For example, if you look at Basecamp, all of that are separate API calls, and all of those are taking a significant amount of time. So putting them all together, doing that single action is not just that one call, but the sum of all of them. So in looking at the lifespan, well, there's two big sections. When everything is tuned out and going very well, you're spending about 80% of your time on the network. While you're on a cellular network, there's bandwidth fluctuate. There's a latency issue there. And then you've got that 20% that's really what's going on in your server. So computing the requests, going to the database if you need to, going back. And that's if everything is tuned out. In some cases, I've seen like the exact reverse. But the real section you've got control of, if you're a backend developer, is looking at that 20%. If you're on the mobile side, then what you want to do is try to have the fewest requests possible to do your action with the smallest payload, even though if you want to get all that information in. So, getting to a better world, we're here. If we can reduce the amount of requests, and there's a couple of tips around that, and get only the information that we need, we can get to a better experience and a better world for our users. Well, getting there is pretty much what I just said. The one thing you want to take advantage of, and a lot of people overlook, is the caching. That's a lot of what I'll be talking about, how you can get caching going on the device. Most API developer will think in a web framework where the browser will cache everything for you. Where on mobile phone, the default, especially if you're writing a native app, the default is actually not to cache anything. That's where you got a big difference. So you got to do all those calls every time, where you shouldn't have to do that. So first step on getting that going and being better at communicating between a mobile application and your browser is being specific with your HTTP header. So I'm mostly talking to the backend developer here. So basic thing. You make a request, the server comes back and says, here's your data. And when you're talking to the browser will store that most of the time, even if you don't put cache header. The default for a browser is actually to cache pretty much everything you give it. When you look at the mobile phone, actually, it's going to get the data and then discard it right away. It's going to process it, show it on the screen. But if you're talking about a native application, most of the time, that's going to get thrown away as the request gets processed. Now, if you're declarative and you say, if your server tells the mobile application, you should keep this data for this amount of time, then, depending on the mobile platform, I'll go in more details after, a bit further down, the phone will keep some of that data. How do you get there? Well, the first thing is for this to work, you need that one object. So that one RESTful API call gotta be one URL. A couple of things we've noticed throughout the time talking with clients backend was you've got, okay. So you've got an object, let's say a cheese database, and they want their application to put in French and English, and they made one object for the cheese, and they look at the request header to say, well, I'm going to give you the description in English if you say your accepted language is English, and I'll give you the description in French if you say your language is French. The problem with that is if your user switches languages, so it started in English and switched the application to French, and I cache the data, then I'm going to start having data that's both French and English. So we need a way to make sure that when I'm talking about a cheese, I'm giving you all the information possible about it, and I want to have collision. Language is kind of an edge case, but I've seen other cases where one object could have more than one URL, or worse, multiple objects have the same URL, and that will cause you a problem when you're starting thinking about caching all those requests. So what do I mean when I say declaring? Well, there's the client side, which is if modified since, if non-match. You got to make sure you ask the server, I already have some data, has it changed? And on the server side, and that's the most important side to start with, is let me know if it was modified, with the last modified. And e-tag if it's something that will change every time I come with a request, but that checksum will let me know if it's actually different. The expires, how long should I keep this in cache? So we know that information is good for an hour, a day, a month. All of that can be handled on the client side and make sure that we keep what you said for the specific amount of time. And if during the operation of the app this needs to change, because there's a lot of change to the content, you can either tune down those time or actually bump them up if you're expecting a lot of load. So I think I went over most of them. So e-tag, e-tag for dynamic content. That's really when a date. Last modify is the easiest one. That's the one you should use by default. E-tag is when your content is dynamic and really a date of modification doesn't apply. A lot of the time that's a record set. So not just one record, but a set of records. Then the E tag, meaning the set hasn't changed, makes more sense than using a last modify and trying to compute in all those records which one is the youngest. Cache control and expires. So cache control is the one you want to have. On the web, expires is honored pretty much everywhere. In mobile application, it's actually cache control. That's the first one the application will look for, especially if you're looking at iOS. So being specific about if the max age, is it revalidated or not, those are the two things you need to look at specifically. On the client side, you need to put those headers. The if modify, most of the API stack will do it for you. The if non-match, you usually have to do it by yourself. If is non-match is for the E tag. So just a quick example of what I just went over using Amazon S3, and one small gotcha you may get into with S3 actually. So any file on S3 will give you a last modify and an E tag. You don't have to do anything, just upload your file on S3 and you'll get either. Now the question is, will it be cached? Well, it won't be cached by default on mobile devices because there's no cache control and no expires. On iOS, if you're lucky, depending on which version you're running, you can expect at most a cache time of the day, most likely 6 hours or not at all. And on Android, it really depends on which API you're using to make your request. If you're using just a standard HTTP request or if you're using a cached HTTP request, you'll get different results. So on S3, what you want to do, and that's fairly straightforward, you can set actually specific cache control headers for your object when you upload them in the metadata. So you just set the Amazon meta cache control, which is the cache control header, and then Amazon will send that cache control header to everyone in your object. In our experience, it's kind of the gotchas that every junior developer will do. They're going to say, well, I'll put all my, for example, profile picture on S3 and won't set the cache control headers. So every single time the application goes out and get that profile picture, you gain a lot of performance if you just cache it for a certain amount of time. You don't really care if it takes a day for my profile picture to change in somebody else's account. You just want that data to be stored. Now, if you look at the same thing on Ruby on Rails, and I'm using Ruby on Rails here simply because it's fairly common and it's easy enough to set up and try out. What I'm going to be talking about with Rails, you really just want to play around with the different settings and understand how cache control will influence your application. I use Elastic Beanstalk to do those different tests. I actually have GitHub if you want to try to look at the code. I use with a fairly small amount of code. And setting it up, well, very well documented on Amazon Developer Network, but going through it, it's a Git repo. You just a standard empty Rails application, and you just start it and look at what happens. So starting with a basic Rails application, the first thing you'll notice is I get the nice E tag. So every single one of my pages are actually tagged with an MD5 checksum, so I can implement caching on the client side. The problem is I'm getting a cache control header. And the cache control header says maximum age 0, private, and must revalidate. So what's going to happen from the mobile application perspective is I'm going to go out, get that content, say you can keep it for 0 seconds, and even if I kept it, I need to go back to the server every single time to validate that it's still good. The reason why most framework will do that by default, and not just Rails does that, most other will do it, is because it's a dynamically rendered page. So they don't want to assume that the content will not change. you've got to take action in either stack you're doing to tell it, no, this content is good for a certain amount of time. And that actually forces you to think about, so what am I returning it here? And what value does it have to user? And how long can we live with something that would have been cached? So fixing it in Rails requires either using fresh when or expires in, ideally both. So fresh when will force the expires header and also the duration, and the expire in will set the cache control duration to a specific amount of time. So in this case, in this example, it's 3 days. I'm saying it's public, and we don't have to revalidate. So whatever comes out of this, the client will keep as is for the next 3 days. And for anything that's like browsing a directory of information, in a lot of cases, you want to have an expire in that's not 15 seconds, but at least hours, if not days, especially if you think your information is not likely to change that much. And the other very important part in there is the must revalidate. Must revalidate is really, really cool. Most people would think to say yes. So the client will go back to the server and say, has this changed? And the server will say, most likely say no. The problem with doing this is on a cell phone, I'm still powering up the antenna, going down to the server, getting the answer back, and that's that 1.24 seconds average. You took 20% out of that, so you're now down to a bit under a second because the server didn't do that much processing, but I'm still down, just going back and forth, it's a second there that I don't want to spend waiting for the server. So if you look at this, I've got a cache control. It says max age 86,400, and it's public. Just by a show of hands, and from what I've said, do you think it's going to be cached on the phone? So anybody says yes? Who says no? We got 3 who says yes, about 5 who say no. Everybody else doesn't know, I guess. Well, it depends, actually. So on Android, the answer is it depends. Really, what you're using to make your network requests. Some have caching built in, some don't. And there's like 20 different ways I can do a network connection in an HTTP client under Android. On iOS, it most likely with all the defaults set, nobody did anything about the cache. It's going to be cached for 6 hours to a day. Because I've got a cache control header in iOS, an SRL connection will actually honor that. And that slide is actually wrong. It should be crossed out. The first bullet should be crossed out. There is a cache control header in that call. Okay. So caching on the device. So what I talked about up to now is what can the server do for the client? How can I be declarative about the different headers I should use, how long the client should store it, and under what condition should it check back with the server if it had changed. On the device, there are still a couple of things I need to do to make sure I can respect what the server wishes are. So if we go back to the big picture of this is the server now goes on and say, here's your data, please keep it for a while. And the device then comes down to where am I going to store this? So again, don't rely on the default. So on Rails, you don't want to rely on the default because you won't get any caching. On your iOS device or on your Android device, it's the same thing. If you go in with the default, top of mind, the iOS default cache size. It's 10 meg in memory, 50 megs on disk, starting with iOS 6. So it's a fairly small amount of data that you can keep in there, especially if you've got images. High definition images will take a couple of meg each. You don't want to go back and get them often. The other thing you don't want to do is hard code that logic. One experience we had was with a TV guide application. And that TV guide application, what we ended up doing, It seemed very logical at the time. We knew that the server would refresh its data twice a day, once around noon and once at midnight. So what we did is on the client side, says whatever the server returns, I'm going to take it and store it. And after that specific, after midnight or after afternoon, I'm going to wipe the data and go back to the server. And we hard-coded that logic. The problem is 6 months into production, we changed the time at which the server would re-import the data, and now we got out of sync. Using the HTTP header means that the server side can actually ensure that if that change, we know when everything's going to expire, we can set shorter or longer delays, and tune out the load on our server as well. So, as you might have guessed, my background is in iOS, and testing this on an iOS device is actually fairly easy. So I'm going to go over how you would do it on iOS, but it's essentially the same on Android. It's really a question of choosing the right HTTP client. So the first thing, in this case in iOS, you want to be specific about how much memory and how much disk capacity your cache should use. I know that my application is going to be downloading a fair amount of images, so I'll go in and say, 100 meg disk cache. That's pretty standard in an application. 50 meg in memory, that's because I think I'm going to be accessing those images frequently, so I want a boatload of them to be just kept in memory whenever I need them. If you don't think you're going to be reusing the same content often, then reduce the memory size and really rely on your disk. It's still flash, it's still pretty fast, so if I'm not scrolling through a bunch of them, I don't need that much RAM memory to be used for the cache, but the disk is the most important one. And the cost of going back to disk is not that big compared to going back to the server or not having the information at all. The other thing you want to look at is your cache policies. So default cache policy is usually just to honor what cache control says. iOS, Android is the same. On iOS, you can also give it a couple more instructions when you make your request. You can say, I want to reload ignoring the cache. So for those specific requests, whatever the server says, disregard it. Or on the other side, you can also say, whatever happens, give me what's in cache. So I'll only go get the data on the first time. And understanding the difference, the different settings as far as cache policies for your specific OS is very, very, very important. Going back and ignoring, the worst one is return cache data else load, is you can get a lot of stale data if you got a big disk cache and you're not wiping through it with new data. The other thing is e-tag. So on your mobile stack, I haven't seen one who deals with e-tag properly. So that means that's the part of cache logic you'll need to implement on your client. Fairly easy. It's essentially a dictionary e-tag URL. When you make your request, you keep that ideally stored on disk, so it's kind of synced up with your cache, and making sure that when you're making your request, you go get, for this URL, the last thing I got was this e-tag, and get the data back. The small gotcha is making sure that you've got that data in cache. What will happen when you implement your own logic around this is you don't sync up your cache and your dictionary of e-tag versus URL. You start with basic logic. I go to my dictionary and say, okay, this is the e-tag for my request. I make the request. The server says it hasn't changed. I get the data from disk. Oh and behold, I get nothing. So now I have to go back, wipe, and do that second request. So now is it going to be cache? And again, most of it should be barred by now. So now that the server returns actually a cache control and it expires, iOS would just specify what's going to happen. And what we know is if we choose the proper cache control on Android, we'll get caching going on the client side. We know that we'll only make relevant requests and that the server will get to decide if we should make those requests or not. So in the end, you're doing more requests because I've got more data locally in less time. I'm giving more content to my user in the same amount of time because some of it is already on the phone. That's all good and nice. Now, the problem, the second thing you need to look at, so now I know I'm caching my stuff. My server is giving me the proper information. You need to measure what the performance of all of that is because you'll be tuning what your cache headers are based on your load, based on the fluctuation in the information. So as more data gets into the database, you may need to cache less of some, more of others. You need to adapt. And if you're not measuring, you don't know if you need to adapt to it. So when we start a project, the first thing we ask ourselves is, what's this application objective? And from there, we'll put a couple of metrics in place to say, this is, we know it's going well if we're serving, if, for example, best example I've got of this is, again, let's go with my cheese directory application. So the cheese application, what it does is fairly simple. You get to see a list of cheese and say I've tasted it or not, and I liked it or not. Just to remember, different types of cheese you enjoyed. So for us, the key metric for this application is user retention and the number of rating they put on cheese. And it could be the same for an application directory. It could be the same. That kind of directory application, often is that the key interaction that works. And so the question that then comes in is, how fast and how smoothly is that process going? So looking at the events around that, the API calls, what kind of return am I getting there, will really help me understand. To help me understand what's the right number, so you're starting a new project, do you know that if it should take 1 second or 5 seconds to do that specific rating action? You don't know. So if you put your metrics in place early, usually before your first user story is completed, your framework of the application should have your analytics in, should have your APM in, should have, of course, crash reporting in. So you know what's happening as you start testing it out and see, I'm doing my first rating ever and it takes 5 seconds. It felt kind of slow, but as good as bad, we don't know yet. And as we move on, making the application, making it better, adding more feature to it, even before 1.0, our QA team usually can inform us as this is too slow, this is too fast. Nobody says it's too fast, but it feels like the action didn't take place. It was so fast, I didn't see it going. So being able to tune what should happen, if you start measuring early, you've got real data to look at and know if you should be doing it. So what measuring all of that means is you'll know what's going on. If you're meeting your objective and does it matter or not that it takes 1 second or 5 seconds. Having an objective will help you do that. Last slide, and it's really ending it off to by Relic friends, is how do you make things better? And you make things better by measuring and knowing what's happening. So I'll invite Nate to come in and show you what Relic can do with both your mobile application and your web backend, and how you can track the performance around that.
Am I on? All right, excellent. All right, my name's Nate. I'm a technical account manager at New Relic, and as PIerre-Luc mentioned, it's really important when you're making these changes just to understand your application's performance, and to do that, you can use New Relic. So New Relic is an application performance management tool, and I'm going to try in about 20 minutes give you a high-level understanding of what New Relic does. So at a really high level, we have agents. So we monitor both the backends and the actual mobile devices directly, and I'm going to show you how we kind of piece that data together. The story really starts with the back end where New Relic started. What we do is we have agents that go inside the application engine. So we actually have agents for anything written in Ruby, Java, .NET, Python, PHP, and Node. Node being one of those really hot languages for mobile applications. So it's pretty neat that we just introduced support for Node. But the whole, so the story starts there. We take those agents, they go into your application engines, they automatically fire up, really easy install, and they start reporting up to our servers where we collect and aggregate that information. You log into New Relic, and you see your data, and what we're looking at here is the data from the back-end applications, your traditional web applications and your traditional, this beacon here is a collector back-end batching application, and it's written in Java, and the RPM UI application is a traditional web application that I'm actually using right now. So we're looking at the web application's performance. So from there, I'm going to take it out to the mobile device where, as Pierre was talking about, understanding that mobile device's performance to what traditionally was your web application backend. So the real story, I'm going to have to start as the RPM UI, understanding just really where New Relic started, and then I'll switch on over to the mobile. So I've clicked here on the overview of this RPM UI application. Again, it's a Ruby application. The agents inside of these 6 servers, as you can see in the upper right here. I'm looking at a 3-hour period where we processed 19, almost 2,000 pages per minute in under 2.3 seconds. So the overview of this application, we understand how long it's taking to get requests out to the end users in a traditional website. So from here, we're going to start diving down deep into the application. So this is the overview of all the pages around the world. As you can see, we've got a graph of the relative performance around the globe, and that's in the map here. So that's out to the end users. Then the application back end is a Ruby application, and we can see over this 3-hour period the performance of these 30,000 requests per minute across the entire 6 servers took around 222 milliseconds. Now I can change the time frame and say, okay, well, let's just look at the last 60 minutes and understand, okay, well, right now, how many people are using New Relic and how many pages are we processing? And you can see here, we're processing pretty much the same 227 milliseconds for 31,000 requests per minute. So now we're going to dive in deeper. And my app does 20, 30, 40 different things. It's processing all these different pages. So now I'm going to understand, okay, everybody around the world is getting their pages in 2.5 seconds in aggregate across my application. But what pages are slow? What pages are fast? What transactions are slow? Which AJAX calls are slow? It's measuring everything and understanding the performance of the different calls to my backend server. And what we can see here is the slowest, or actually the most time-consuming transaction is this recent events transaction. If I click on that, over on the right, I will see the understanding of how long it takes to process the recent events transaction. On average, it takes 800 milliseconds, and it's called 900 times per minute. So now I'm getting a little deeper in understanding the different calls and how long they're taking. And you can see here that most of the time is spent, this is a layer graph, most of the time spent in code, but there's a little bit of time in the database. I can also get a breakdown table of the different components in this transaction. But really, what we're really doing is we're going to get to this point where we got a transaction trace. Now, a transaction trace is an individual call into the system. Where New Relic presents a lot of information, gathering it from many, many data points, users around the world, these 6 servers. To make sense of these millions or thousands of data points, we aggregate a lot of data. What's the performance of my application out to end users at the mobile device? What's the performance across all of my servers? How well is this transaction being processed? But a transaction trace is an individual call that gives you actionable data about what actually happened when that call came into the system. So we can see here that this call happened just a few minutes ago. It took exactly 4.7 seconds to process on the server side. We can see how someone was calling this transaction. This URL was here, and we've added some custom parameters. So we know exactly in production how this call came into the system. And we click on the trace details, we get the call stack in production of what actually happened. At time 0, the call came in. We spent 11 milliseconds doing these 5 fast things. I called this specific database call. It took 1 millisecond. So these things were not the slowdown in terms of when this call, why did this call take 4.7 seconds? It took 4.7 seconds because we have this setup event list, set of functionality, and we actually end up calling the database several hundred times as I scroll down here. It's an inefficient pattern in Rails, pretty common because of OR mapping. But as I can see here, it took 4.7 seconds to call the database, probably 300-400 times. In and of themselves, this database call only took 6 milliseconds. That's not the problem. It's the fact that I'm doing it 400 times and it ends up taking 4.7 seconds. So that's transaction trace functionality. It really is that meat and potatoes what New Relic does. It gives you that deep visibility in your backend. So now let's step back and bring this back full circle to the mobile. Yesterday, New Relic introduced an open beta for our V2 of our mobile. So I'm going to be sharing with you what this new features that we just announced will provide. But before I get there, the agents do have a built-in map functionality, and this is really going to paint the picture why I started with the backend first. So as we can see here, the RPM UI application is sitting here in the middle, and this map functionality is automatically dynamically generated on actually what's coming into my application and what my backend or what my application is talking to. And as we can see here, we've got end users, which were what we talked about in the beginning. What's the performance of my traditional web application out to browsers around the world? And we can see that's the same graph as we had before. We can also see that there's a documentation application that gets information from my RPM UI, which is my backend application. But we have a native mobile solution where you can go to the App Store, you can look at all the New Relic data directly from an iOS device. So within that application, the mobile device is talking, and this is the performance of the mobile device to our backend. So you can see that in the map and how all these things are interconnected. If I click over here on the left on mobile, you can see that we at New Relic are monitoring our own applications, and we actually have a few demo ones. The production one is called the New Relic for iOS Production. It's basically an app that you can go and you can look all this data. Into that application, we have installed our mobile monitoring SDK. So what this is for Android or iOS, you go to New Relic, you download an SDK, you link it into your application, you compile a couple things, and then once it gets released into the App Store, you might have 100,000 million users. Our agent automatically is going to start collecting information from those million devices, and we'll collect and aggregate all that information for you, and present you this data here. So that's the mechanics of how we get our agent onto your application. And when you're trying to understand, I'm trying to make my application as fast as possible. First is just having the agent. What is its current performance? And then you can work on these caching techniques to, and you can use New Relic to confirm that, hey, we made this big change, we spent a lot of effort in here, and we can measurably see a performance improvement in terms of our applications out on those devices. So I'm going to jump in here. Once you have the agent on those devices, it's out there in the wild, this is the kind of measurements you can get. You can see that over the last 60 minutes, we had 24 active, 25 active users using our application, and this is how they're, and where are they in the world? We've got the performance around the world, and they're talking to different back-end systems, right? Generally, when we write these mobile applications, they need to get data from certain places. Our application, it's kind of small here, talks to Gravatar, it talks to staging.newrelic.com, and it also talks to API.newrelic.com. If we go to the network, which was a big focus of this, right? Anytime I have to go and get something from the back end, how long does it take? Well, we can see across these 25 users, on average, it takes 1.4 seconds to get a response back network-wise from Gravatar. And from New Relic, to get the data to fill the New Relic charts about how my web application is performing, on average, it's taking 1.4 seconds. But because I have an agent in that back end tier, I can see right here that I'm talking to RPM UI. And I can see that the slowest call overall is this components controller index. It's kind of hard to read, a little small. But this is the performance when somebody is using the device and they're trying to get the performance from the components. This is how long it's taking to get a response back from that back end tier. And since I do have an agent on that back end, I can actually drill what was the performance of this person's device, getting some information, and I can drill back down into the transactions that's on the server side. So there's a nice connection between what I traditionally wrote for just an end user's browser. I can see that same interaction from a mobile device down to that, the back end tier, and maybe you can see that the users on the mobile device are having a poor experience because the database is really, really slow. So you just connect all the dots together. So that is, there's a lot more features in terms of our mobile monitoring, in terms of our back end. We've got, how fast is version X performing? How fast is version Y performing? What is the OS metrics? How well does my app run on iOS 7.01 versus 7.02, for example? Can do all these comparisons because we're gathering all these data points. The first version of New Relic basically focused on that network performance. The V2 that we announced for beta yesterday, you can go to the site right now, sign up for a free 30-day trial in New Relic. You can download the SDK and get the new version here. Focuses on what we call interactions. The biggest feature is interactions. So instead of just knowing how long did it take to, for network packets to get back and forth, when I made specific API calls, how long did it take when I pushed this button for it to get that information and then render on the screen? So these are called interactions, and it's different than the transaction trace that I showed you because the transaction trace is a single-threaded operation where you're processing a request, talking to the database, talking to PayPal, finishing the request, and building a page and sending it to the end user. That's what these back-end servers are doing. On a mobile device, you have access to fire off threads and basically do a whole lot of managing of layouts, and then the end result is you get a rendered screen. So there's a little bit more going on. So what I have here, so when I click the app interactions, basically we're going to start and stop timers on mobile devices, particular functionality. I really like Uber, so I always like to use the example of what would be the amount of time it would take if I click the Uber button, and how long does that interaction take until it comes back and say, hey, your Uber is arriving, or it's been picked out and it'll be there in 5 minutes. And that's what the interactions are a measurement of. I'm going to switch here to, oh, here we go. So over the last 24 hours, these are the different interactions that we've had. View did load. These are just the names of our transactions, not super helpful in terms of what might mean something to you. But this is pretty neat. This is one of the calls that came through yesterday. And you can see the interaction of the memory. So when we talk about caching, like what was the effect of calling this transaction on the memory of the device? We can see the interaction of the memory, the interaction of the CPU. At time 0, we started this interaction. We have a main thread. And then it fired off 6 different threads, paused in terms of its interaction. It took exactly 2 seconds to do this interaction. And as you can see, we fired off these threads. They did this call stack here that was basically dispatching for some information. Further on down here, we made a network call. It took it took 200 milliseconds to call on the backend server. Once we got that off, we fired off another thread to help render this. It's a layout. Once it was laid out and rendered, that interaction was done. So all of these things piece together to understand, okay, across, let's imagine, if you would, you release your app to the App Store. You have a really big success, and you have 1 million people using your device. We can understand each one of the interactions across those 1 million devices. How long does it take on average? And then we're going to pull out individual interactions and give you that visibility. So I can see at time 0, these are calling in, and I keep seeing myself going back, calling network, using the network to pull back a picture, my profile picture. Why don't I make a change to cache that data, and then use New Relic? Once you make that change, you can come back and say, okay, we have a marked improvement because we cached that. We went from 3 seconds for this interaction down to 2 seconds, and we can confirm that we're not going back and getting that data from the back end here. That's really kind of tying it all together. I believe we're going to open it up for questions. 2 minutes. I only have 2 minutes left. If you have any questions about New Relic or caching, we can field any of those. Doesn't look like anyone's got any questions today. So thank you very much for your time. We appreciate it.